Hello. Today's topic 4, day 3, proving triangles congruent using ASA or angle side angle and angle side. Our learning objective: I can prove two congruent triangles congruent as using ASA and AAS. When we look at this, we can zoom in. We can first talk about our congruent statements. And so if we look at number 1 of this, we have triangle JKI is congruent to. And so in our triangle congruent statements, we're talking about using a set direction. So I know it's going to be triangles congruent to triangle. And I look to see as saying, oh, well, J matches with what other angle? Well, J has one arc, so it has to be T, because T also has one arc. So I know that T has to be the first letter. I look at K. K ends up having the 2 double arcs. So that must mean it's R. And to verify, I look at JK. JK has the 1 dash. The TR also has the 1 dash. But I'm not quite done yet. I know the last one has to be the third point, which is RS. And so we verify RS is the same as KI because they're both double marks. And then ST is the same as IJ because they're triple marks. We'll look at number 2. Oops. Okay. Number 2, we have triangle BCD is congruent to what? Well, BCD, B has the 1 arc. So on the other triangle, GHI, I look for the other 1 arc, which happens to be G. So I know it's going to be triangle G. Then I look for the next one. And the next one is C. So I look at C. And it's the double arc. So I come over here. The double arc should be H here. It is also connected to GH and BC. Both of them are single marks or single dashes. So they're the same. Then the last one is I, and you verify that it's 3 marks. It's connected by a 2 dash, 3 dash, and you go through that process. Try the next 2 for yourself. Okay, so on this one should be Q, P, D. Okay, there's 2 Q's here. One's a double arc, one's a single arc. You need to make sure that you're talking about which one I'm talking about. Same thing with P. P here is a single arc when it's PQR. So these 2 are the same. So get number 4. Try number 4 yourself. Same thing. S, double arc, R, T. So you have to pay attention to that kind of stuff, seeing where those pieces come in. All right, let's look at number 5. So given triangle ACB is congruent to PRQ, sorry. Write and solve an equation to find the value of x. I know two angles on one, and then I know one angle on the third. Knowing that this side, RP and AC are the same, and RQ and BC are the same, I can state that angle R and angle C are the same, okay, because they are corresponding parts. You also can verify that because C is in the middle, R is in the middle of the congruent statement, means that they are the same thing, which means that C is also 4 times quantity x plus 3. Knowing that, I can write all three of those up. All three of those up. 4 times the quantity x plus 3 plus 47 plus 29. All three of those angles should add up to be 180. Then I distribute my 4 all the way through. 4 times x is 4x. 4 times 3 is 12. Then I can combine like terms. 12, 47, 29 are all like terms. And that gives me 4x plus 88 is equal to 180. I subtract 88 on both sides. That gives me 4x is equal to 92. I divide by 4. Divide by 4. X is 23. All I want to know is what x is, so we're done. Number 6 says, in the diagram below, triangle TJM is congruent to triangle PHS. Set up and solve the equation to find the value of x and y. So once again, we have two triangles. They're set congruent to each other per the congruent statement. And we need to know what x and y is. I'm given all three sides for one triangle, and I'm only given one side for the other triangle. Well, all three have y as a value, and I don't have a perimeter, so I can't use perimeter in all three sides to help us. But I can use the fact that pH is going to be the same as one of the other sides here. So I have to find what that is. Well, pH is here, the first two letters, so it has to be TJ. TJ is right here. And so I can set those equal to each other because they should be the same. So I take pH, which is 2 times 6y plus 2, and set it equal to 10y plus 9. I distribute my 2 all the way through. 2 times 6 is 12y. 2 times 2 is 4. Then I get y's all on one side. So I subtract 10y on both. Leaves me a 2y plus 4 is equal to 9. Then I subtract 4 on both sides. Gives me 2y is equal to 5. Divide by 2. Divide by 2. That gives me y is 2.5. Or you can leave it as 5 over 2. The other aspect of it, that's annoying, is to find X. Okay, so I'm going to change the color on this. And so I look at this and I say, well, X is an angle measure. It's the angle M. I don't know if I know where every piece is. And I know that pH is the same as TJ, which means that P is the same as T. So I know it's not 73. I know that H must be the same as J then, which means M must be the same as S, which means that 2X plus 18 should be 48. And if you look here, M is last, S is last. Both of them should be the same. So I subtract 18 on both. Gives me 2X is equal to 30. I divide by 2, and it gives me X is 15. Now let's look at number 7. It says, mark the picture as you use the given information to show the congruent pairs or congruent parts. The first pair of sides is filled in for you. AC is congruent to DE. AC is congruent to DE. And the reason for that is it's given. It's a given piece of information. The others aren't really talking about any kind of congruent sides or angles. It's talking about using our information to help us. And so the first piece of information I'm going to look at is the fact that B is the midpoint of CD. B is the midpoint of C to D, which means that this is the same as this. So I can make the statement CB is congruent to BD because it's the definition of midpoint. Then we look at the last one. CD bisects AE. CD bisects AE, which means that CD, this line right here, cuts AE in half, which means that those three pieces should be the same. So I know I can state A, B is congruent to B, E. And this is because definition of bisector. Notice I'm using the terms that are given to me, midpoint, bisector, okay, as a way to prove it. Now I look at my angles. The other two pieces of information that I have is that AC is parallel to DE. And so if I look here, this DC is a transversal intersecting two parallel lines, which means that angle D And angle C should be the same. Angle D is congruent to angle C because of alternate interior angles there. They're both inside the parallel lines. They're both on opposite sides of DC. So they must be the same. AE is also a transversal. So here and here are also the same. They're different than C and D. But I know that A is congruent to E is also alternate interior angles theorem. The last one is angle B. Well, angle B shows up in both. And so if you look here, this angle here is going to be the same as this angle. Angle B is congruent to angle B. And that is by vertical angles theorem. Now that I have all three sides congruent and all three angles congruent, I can make the statement triangle A, B, C is congruent to triangle E, because E matches up with A, B matches up with B, and D matches up with C. We look at the proof, the next thing. It says given BC is a bisector of AD, angle BCA and angle BCD is congruent. BC is the angle bisector of angle BD, ABD. AB is congruent to BD. Angle BAD is congruent to BAC. So we're going to go through this. We're going to mark up the diagram, and then we're also going to look at the reasons. Okay. The very first statement is everything that was given to me. So I'm going to just write given in my reasons because it was given to me. The first statement, if you look at the justification, says definition of angle bisector. Okay. Definition of angle bisector uses this part of the given. And that means I'm cutting ABD in half. Well, that means I'm cutting here and here. So I have two parts to it. This angle is ABC. So I know that has to be angle ABC. Angle DBC has to be the same because it's a definition of angle bisector. So now I'm given that this angle is the same as that. I'm also given that BCA is the same as BCD. I'm also given that BAD is the same as BDC. So with that one angle on number 2, with that one angle, I'm able to say all three angles are the same. Now AC is equal to CD. AC is equal to CD. And I want to know why. Well, BC is a bisector of AD. So I know that we use the definition of a bisector here. They also gave me that AB and BD are the same in the given. The last thing I need to do to be able to prove congruent triangles is to prove the last line, BC, to be the same. Well, BC is congruent to BC because when you are yourself, you are congruent to yourself, right? So you're going to be able to say, yes, BC is congruent to BC. And that is by the reflexive property. Which is a property that states that you are congruent to yourself or you're equal to yourself. Now that I have this, I've proven all three sides, I've proven all three angles. I can now state that triangle ABC is congruent to triangle DBC. And it's the definition of congruent triangles in this case. Pause if you need time. So if you know that all three angles and all three sides match up and line up and all that stuff, you can tell that the triangle is congruent because of the definition of congruent triangles. However, there has to be a better way than having to crank out all of those all the time. And so there is a better way. You can prove that two triangles are congruent without showing that all the corresponding parts are congruent. But in this lesson, you'll prove that triangles are congruent using one pair of corresponding sides and two pairs of corresponding angles. And it's used by these two theorems. The first theorem is angle side angle theorem, or ASA. And ASA reads, if two angles and the included side of one of the triangles are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So an example, if L is congruent to R and LM is congruent to RP and M is congruent to P, then I can state those two triangles are the same. Notice it is angle, then a side, then two angle, another angle. It has to be an angle, then a side, then an angle. Like the side has to be connecting to the two angles in between. That is angle, side, angle, ASA. And the reason why we call it ASA, angle, side, angle, it kind of reminds us that the side has to be between the two angles. The other form is called angle, angle, side. It says if two angles and a non-included side of the one triangle are congruent to two angles and the non-included side of another triangle, then the two triangles are congruent. So an example down below says T angle S is the same as angle X. Angle T is the same as angle Z. RT is the same as YZ. Okay, so these angles are the same. So I have angle here, I have an angle here, and then I have a side. The side is attached to a single arc here. So I look over here, the single arc here, and the side's attached to it. So we're attached to the right spot. We're in the corresponding part to it. That's important because if it was attached to the other angle, it would not be proving. But notice it's angle, angle, side, angle, angle, side. When the side's on the outside of the two angles, it's going to be angle, angle, side. Pause if you need to write it. So example 1, it says state if the two triangles are congruent. If they are, state how you know. Well, I'm given that B is the same as E. C is the same as C. E and the side in between the two angles are the same. Since these are following angle, side, angle, this is a yes. And I know this because it's angle, side, angle. This one, here's an angle, here's an angle. This matches with this. And then the side is a mutual side, but that mutual side is on both. And here's an angle, here's an angle, here's a side. It does follow suit, so this is a yes. And it's by angle, angle, side. This is also congruent to here. This arc is congruent to here. These might not be here. They might not expect you to know, or might expect you to see that they're vertical angles, in that they are congruent. So this is also a yes. And it's angle or angle side. We don't typically do side angle angle. It's always going to be angle angle side. Only because I want to know it's a non-included side. So the next one is a proof. So let's talk about this proof. It says copy the problem down on your notes, then click the picture to watch the video. Well, we don't have a video, sorry. So let's go through this, okay? It says given line LN bisects angle MLO and MNO, okay? It bisects MLO, so I know that this and this should be the same by definition of bisecting. Then it also bisects M and O, which means that this should be the same as that because it bisects. So let's talk about this part and get that going, right? Line LN bisects angle MLO and angle MNO. And that is given. So I need to make the nuances, the actual angles. MLN is congruent to OLN. And the reason behind that is the definition of bisector. Because when it's bisecting, it cuts it in half. Same thing for number 3. I'm going to make M in L congruent to angle O in L. And that's also the definition of bisect. Now, the two ways of being able to do it without having to show that M and O are the same, and then all the 3 sides, is to show that a side that's either on the outside of those 2 lines or the side that's on the inside that are the same. Well, LN is on both triangles. And since it's on the both triangles, I can say that it's the same to itself. Okay. LN is congruent to LN because that is a true statement. it is always going to be okay to say it's congruent to itself. And it's called the reflexive property. The reflexive property. The last bit allows me to prove that LMN is congruent to LON. And it is angle, side, angle, theorem. Go ahead and try 1 and 2 together. All right. Try 1 and 2 and then unpause and then go through the answers. So 1 is all about, can the triangles be proven congruent? Explain why using a shortcut, or why not. This one is a yes. And that is because this line is the same for both. And there'll be angle, side, angle. If you look at B, this angle here, the same as that angle, which means I'm going to have angle, angle, side. So this is a yes, angle, angle, side. Angle C, or 3, the C is a no. I can't use the shortcut because it's missing a side congruence. And I can't prove that the sides are the same. I can prove the third angle the same based on what I have, but I can't prove the sides. Do the same thing for 2. Number 2, so state the additional sides or angles that must be congruent in order to prove them to be the same. If I wanted to use AAS, I need a side outside of the triangle. So I would need to know that BC is congruent to EF, or FD is congruent to CA. I would need to know that. One of those two. It doesn't matter which one. I would just need to know that one. If I would look at the triangles for B, okay, to do angle, side, angle, angle, side, angle, I have to prove that F, angle, side, angle is congruent to angle C. To have that ability to say angle, side, angle. Looking at number 3, it's a proof. It says given line KJ is congruent to line MN and angle J is congruent to angle N. I want to prove that those two triangles are the same. Well, I already have beginnings, and I can either do side, angle, side, or sorry, angle, side, angle, which means I'm either doing K and M, or I can do side, angle, angle, or angle, angle, side, which means I need to deal with angle L. Well, I can tell you that angle L is the same on both sides because angle L is a set of vertical angles. And that's all I need. I need this piece. So I can say angle L is congruent to angle L because of the vertical angle theorem. They're congruent because of angle, angle, side. Try the next one. Given QS is parallel to TR and S is congruent to TR, angle R. Okay. I look at the statements. They give us our givens, QTR, 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 this thing right here, says it's the same as TQS because QT is a transversal on two parallel lines. Since it's two parallel lines cut by a transversal, these are on opposite sides of the line. That's called an alternate interior angle theorem. Oops. Now I'm giving us angle, 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 angle. I can't give a side to be the same. That is on the in between because I don't know if QS are the same. I don't know if RT is the same, but I know QT is on both triangles. So I know that this is the same as itself and it's by the reflexive property. So QT is congruent to QT by the reflexive property. Now I have angle, angle, side. So I know that triangle QTR is congruent to triangle TQS by angle, angle, side. Here. If we look at number 5, AE is parallel to BD. AE is congruent to BD. A or E and D are the same. Those are all given information. These are parallel lines. ABC is a transversal, which means that this angle right here and this angle right here are the same. So I can say that angle A is congruent to angle B because A and B are corresponding angles. So it's corresponding angles theorem. Now I have an angle, I have a side, and I have an angle. So I can state that the triangles are the same by angle, side, angle theorem. Try number 6. Don't go from there. AD is parallel to EC. BD is congruent to BC. That's given. So that's the very first thing I do. Okay. AD parallel to EC. It's given. BD is congruent to BC. Now, there's a number of ways you can prove this, but I can state that B is congruent to itself by vertical angle theorem. Then I can either go angle side angle or side angle side, sorry. Either one, it does not matter. If I wanted to do angle side angle, I want to prove that angle D would be congruent to angle C. And it's possible because AD and CE are parallel and DC is it transversal? So this angle and this angle are alternate interior angles. So I can say angle D is congruent to angle C by alternate interior angle theorem. Once I have angle side angle, I can make the statement that triangle ABD is congruent to triangle EBC by angle side angle. Thank you for watching this. Thank you for taking the notes. Go ahead and go to Schoology and get to work on your homework / other homework or other practice that you need to work on. Thank you. Have a good day.